Hello everyone, welcome to my mini lecture on cubics. So a cubic is something similar to a parabola, except we now have a third x-intercept. So the general form of the equation that we will be using for a cubic is y equals k times x minus a, x minus b, x minus c, and that'll be the factorized form of the equation. If necessary, you can expand the brackets in order to get something in y equals kx cubed plus lx squared plus m times x plus n. But in general, we're just going to continue working with the factorized form. So here we see the parabola associated with the graph of y equals x minus 1 times x minus 2. And you can see here that there are two x-intercepts, which are 1 and 2. So this is just a follow-on from the quadratic mini lecture. Now, if we add in a third x-intercept, so we now have intercepts at 1, 2, and 3. So this is the cubic equation y equals x minus 1, x minus 2, x minus 3, and that 1, 2, and 3 in the equation correspond to the x-intercepts there. Now, if we continue adding x-intercepts, we get more and more complicated looking graphs. So if we add in another x-intercept of 4, we get something that is called a quartic. So if we expand out those brackets, we would get something with an x to the power of 4 there. And if we continue in the same vein, so we add a fifth x-intercept as well, we get a quintic. But we will not be worrying about quartics or quintics. We'll be worrying about parabolas and cubics. So here we have a cubic equation, a cubic graph, and we need to find its equation. So the starting point is the general form of the equation, which is y equals k times x minus a, x minus b, x minus c, and we look for what our three x-intercepts are, which are in this case -2, 1, and 3. So we've got y equals k times x minus a. Well, a is the first x-intercept, which is -2. So we've got x minus -2, which is x plus 2. Second intercept is at 1. So we've got next bracket is x minus 1. And the next bracket is going to be due to the third x-intercept, which is at 3. So that's going to be x minus 3. Okay, so then we need to find what the value of k is, and we can use any point other than the x-intercepts. The easiest point to go with here would be the y-intercept, which is 6. So when x is 0, because that's an y-intercept, x is 0, y is 6. So if we put that into our equation, we've got 6 equals k times 0 plus 2 times, replacing all of these x's with 0, 0 minus 1, and 0 minus 3. So working out each of those brackets in terms, 6 is k times 0 plus 2 is 2, 0 minus 1 is -1, and 0 minus 3 is -3. And then if we multiply 2 times -1 times -3, that gives us 6. So therefore we have 6 equals 6k. And if we divide that through by 6, we get k is 1. Okay, so if we substitute k equals 1 into the line where we put in our x-intercepts, which is that line back there, our equation is y equals 1 times, but we don't need to write 1 times, so it's going to be x plus 2 times x minus 1 multiplied by x minus 3. So that is the equation of that graph. Now with the next cubic we see there, So let's work out what our x-intercepts are, which are going to be, in this case, -2, 0, and 2. Okay, so we also notice that this cubic has a general downwards trend. Starts off going down, then it's going up for a bit in the middle, then going down again. Overall, the whole thing has this downwards trend, which means we are expecting a negative value of k in y equals k times x minus a, x minus b, x minus c. So we should get a negative for our value of k here. If we put our x-intercepts into that, we get y equals k times x minus -2, which is x plus 2. The middle x-intercept is 0, and then we've got x minus 2 due to that third x-intercept. Now we can tidy that up because x minus 0 is just x, so we've got y equals k times x minus 0. We'll bring that one to the front to tidy it up. So we've got k times x plus 2 times x minus 2. Now, because we've got an x-intercept of 0, that means that we have a y-intercept of 0 as well. That's at the same point, which is at the origin. So that point is not going to provide us any new information. It therefore will not allow us to find the value of k. And to find the value of k, we will need to use any other point. The other point that's probably going to be easiest to work with would be this point there, which is when x is 1, y is 3. So that's what we'll substitute in to find our value of k. So we've got, if we substitute that in, we get 3 equals k times x is 1, x is 1, 1 plus 2, and x is 1, so that's 1 minus 2. And then working out the brackets as before, so we got 3 equals k multiplied by 1, we won't write. 1 plus 2 is equal to 3, and 1 minus 2 is -1. So therefore, we've got 3 equals, 3 times -1 is -3k. And if we divide that through by -3, we get k equals 3 divided by -3, which is -1. And therefore our equation for that cubic is y equals k, which is -1. We'll only need to write the negative. And then we have an x at the front, because we're substituting -1 back into that line of working. So we've got -x times x plus 2 times x minus 2. Could even substitute into the more simplified line of working directly below it, but before we substitute in the point that gives us the value of k. Okay, so that cubic has the equation y equals -x times x plus 2 times x minus 2. And our last question for this mini lecture is to work out the equation of this thing. So we notice that this one only has 2 x-intercepts at -4 and also at 3. But the other piece of information where the third x-intercept comes from is the fact that it's turning right on the line there. So it's touching and turning, which means we have a double intercept at that point. So y is k times x minus a, x minus b, x minus c. And since it's touching and turning at -4, we can treat it as though there are 2 x-intercepts at -4. So we've got y equals k times x minus -4 is x plus 4, and b is going to be the same. B is also going to be -4 due to turning right on the line there. So it's x minus -4 is x plus 4 multiplied by x minus c. Third x-intercept is at 3. So we've got k times x plus 4 times x plus 4 times x minus 3. Let's tidy this up a little bit. That's going to be x minus 4 times x plus 4 times x plus 4 is x plus 4 squared multiplied by x minus 3. Now, we do have a separate y-intercept here, which is again at 6. So that means that we are free to use the y-intercept with this question. We weren't in the previous question, but here we can. So when x is 0, y is 6, and if we put that information in, we get 6 equals k times 0 plus 4 squared multiplied by 0 minus 3. And therefore 6 is equal to k multiplied by 0 plus 4 is 4. So this is k times 4 squared multiplied by negative 3. So therefore, let's work out the 4 squared is 16. So we've got k multiplied by 16 multiplied by negative 3, which is going to be 6 equals k times negative 48. And if we divide that by negative 48, we get k equals 6 over negative 48, which is negative 0.125. In other words, negative 1 over 8. And because we do have that top left to bottom right trend, we are expecting a negative value of k. So our equation here is y equals negative 0.125 multiplied by x plus 4 squared multiplied by x minus 3. So that concludes the mini lecture on cubics. Thank you for watching.